All right. Hey, Algebra 2. I'm looking at some notes today. 3-7. It's Sunday night actually, but I'm making these notes now for the week. So 3-7. So let's look at it. We're getting to factoring quadratics, which should be familiar from Algebra 1. I keep saying that because we're just reviewing Algebra 1 basically. Let's see. Let's zoom in. So this is notes 3-7 again. Let me zoom in here. And we can look at it. So factoring, very important skill. Factoring is basically breaking down stuff. And it's kind of the opposite of multiplying something together. So we're going to do like 3 examples and then we'll talk about factoring. So let's start off with some examples. I'm going to do the ones that are more towards the right here. So I'm going to look at, I'm going to start with, let me see if I can move this here. This, screen sharing, move it over here. I'm going to annotate like this, and I'm drawing, and I'm looking at this one here. Like that. Big, right? This one, there we go. So looking at C, let's go ahead. And I'm going to do some examples, and we'll talk about what factoring is. But first we need to kind of have a reminder on multiplication. So this is number C from the notes. So we have A, B, some value A, B, times 2 minus 3b squared plus a. So how would we solve this? Well, this is just, again, distribution, multiplication, distribution. Just multiply everything to the 3 terms. This is a trinomial here, so you're multiplying everything. So ab times 2, ab times 2 is just 2ab. AB times negative 3b squared, it's going to be negative 3, right? Because really it's 1ab. We don't write the 1, but you can think of the 1 there. 1 times negative 3 is negative 3. There is no a there, or it's just 1. So a times 1 is a, so that's a. B times b squared, remember b times b squared is really b times b, so it's really b times b times b, that's just b cubed, right? b squared, b cubed, plus ab times a, again, is a times a, which is a squared, and then there's only the b and the ab, so it's just b times 1, right? So ab times 2 is 2ab, ab times negative 3b squared is negative 3ab cubed, and then ab times a is a squared b, right? So just multiplying everything into it. Let's look at another one. Let's look at, okay, so there's that. Let's look at E. Very similar to this one. Very similar to this one. Same basic concept. You have here some negative xy, some value on the outside of the parentheses. You're multiplying that times x squared y plus 5x minus y. Again, when you multiply, you're going to distribute. You're going to multiply the coefficients together, and then you're going to add the exponents is a way to think about it. So negative xy times x squared y, well, it's a negative times positive, so it'll still be negative. So negative there. X times x squared is x cubed. Y times y is y squared. Negative times the positive is negative. This is 1xy times 5, so it's going to be negative 5. X times x is x squared. Y times just 1, this is y. And now I have a negative here, the minus y there, so it's going to become positive because the negative times negative is positive. X times, this is 1x here, y times y is y squared. Right? So again, we're just multiplying, it's just distribution, which is just to remember that word. It's always good to try to speak in math terms. Distribution. That's all we're doing. Distribution. Let's do one more of these problems here. Let me erase that. And we'll focus on, let's do F. Last one here with a fraction. Still essentially the same thing. You're just distributing. So 1/2 here times what this? 8b cubed plus 6a plus 30. So here we don't have an exponent, we don't have a variable that we're multiplying in front of this expression. We just have 1/2 times this whole thing. So again, just multiply everything. what's 1/2? Here you have 8 something. 8b cubed is the something, but 8 of something. 1/2 of 8 is 4 of that something. So 4b cubed. You have 6 of something. Here it's a. 6a. Half of 6a is 3a. And then half of 30 is 15. So again, that's just distribution. You're just multiplying everything against everything, right? Distribution. Now, why did we talk about distribution? I thought we were talking about factoring. Well, let's zoom out for a second and think about this. There's a reason why we did it. So again, the above process, the thing we just did, is really, it's really multiplication. Multiplication. In this case, you could also say that's distribution. Distribution is just multiplication. They're not really different. It's the same thing. The math operation we are doing now, that's the opposite of this, is factoring. Factoring is the opposite of distribution. Distribution, you can also think of that as like combining. Right, I'm putting it in quotes because like it's not really what we're doing. We're kind of combining, and then factoring is really like you can say taking apart. Taking apart. It's like I'd say it. Multiplication, distribution, combining. Factoring is really taking apart. How can you take apart something? How can you break something up and see what they have in common and then break things down? So that's essentially what we're doing. I'm going to erase that. If you need to write it down, just pause it. Yeah, you know how to use a video. The good thing about making a video is I can go as fast as I want. So we're gonna look at how to break things down. I'm gonna do BEG. I'll start with B. Let me put this here. So we're trying to find the greatest common factor, which is again breaking things up and finding the biggest value that's in common of all our terms. Some tips about factoring a GCF is you could the GCF could be a constant only, it could be a variable, it could be both a constant and a variable, it just depends. So let's look at, I'm going to zoom in even more. B here. B is what we're looking at. I don't know why I have to box it. I said the letter B, you should know what I'm talking about. Okay, this example here says 4x squared plus 20x plus 16. So here's what I do when I'm factoring. I don't always do this, but like here's a way to think about it: is breaking everything down into its components. So you might remember the word prime factorization. Prime factorization. Let me write that down. Prime factorization. Prime factorization is breaking something into prime numbers. How can I break it into prime numbers? That's really what that is. Yeah, make it really big. Prime factorization. That's what we're doing here. So 4 is really 2 times 2. Both 2 is a prime number. So 4 is really 2 times 2. X squared is really x times x, right? That's really what 4x squared is. It's 2 times 2 times x times x. 20x. 20x is really, let's break this down. This is really 4 times 5 times x, and really 4 times 4 again is 2 times 2. So I'm going to break that down even more. So 20x is really 2 times 2 times 5 times x. And then the last thing we have is the 16. 16 is really 4 times 4, which you could say is really 2 times 2 times 2 times 2. That's really 4 times 4, or 16. So you break it down into prime numbers. Prime numbers are numbers that can only be divided by itself and 1, not including 1. So prime numbers would be like 2, 3, 5, 7, 11, 13, 17, 19, and so on. You don't really need, there's more than that, but that's fine. So you're saying, what do they have in common? Okay, well, this has 2 2s, and this has 2 2s, and this has 2 2s. They all have at least 2 times 2 in common. This has an x, that has an x, but there's no x here. So they don't have an x in common. All they have is the 2 times 2 in common. So they definitely have 2 times 2 in common, which is 4, right? I'm going to just write down 4. They definitely all have 4. So once you factor that out, what's left? All right, well, here you've got x squared. You have x times x squared. Here you have the 5 in the x, so 5x, x squared plus 5x. And then here you just have the 2 times 2, so 4. So you got 4 times x squared plus 5x plus 4. If you were to distribute this back out, you would get what you started with. You'd get what you started with, right? 4 times x squared is 4x squared. 4 times 5x is 20x. 4 times 4 is 16, right? That's what we started with. So again, factoring, which is like the breaking apart, and distribution, which is combining, those are sort of, they are opposite of each other. So opposite of each other. Okay, let's do some more. Let's do this over. Let's now look at, in red, I'm going to do E. E here. Let's write this right here. Say it to the face. Okay, E. 2x cubed minus 4x squared plus x. Now, immediately you might notice that, there's a 2 there. 4 is 2 times 2. I have nothing here in this third term. It's just x. So, if I'm breaking stuff down, this is really 2 times x times x times x. That's x cubed. You got 2 times 2 times x times x. That's 4x squared. And you also have just the x by itself. So what do they all have in common? They just each have an x. That's all you can factor out. You don't always factor out more than, it might just be one thing. It might be a lot of things. But here's just one thing. So if I take away the x from 2x cubed, I'm left with 2x squared. If I take out an x from negative 4x squared, I'm left with just minus 4x, because there's that minus, so there should be like a minus 2 there. If I take out the x here, there's nothing left, or you don't see anything. You can always think about the 1 being there, right? You could say x is really x times 1, so we factor out the x, but there's still the 1 there. So I'm going to put a plus 1 there. And there it is factored. You found the GCF. The GCF here, the greatest common factor is the x. All right, let's do maybe two more, and hopefully, again, this is review. You did this in Algebra 1. Hopefully you kind of remember this a little bit. Let's see, cancel that. Let's pick some more. Let's do maybe F and G. So let's maybe do this. I'll always highlight which one I'm doing. There, I'm doing it. I don't know why I do that. I mean, you can hear me say the letter F, but just in case you didn't know. X cubed minus 18x squared plus 45x. Okay, so let's look at that. What do they have? Let's break it down. This is sort of like the last one we did, where I see the third term here only has an x, so I know I can only factor out some x. That's all I can factor out, because 18, right? Negative 18. That's 2 times 9 is 18. 2 times 3 times 3, because 9 is 3 times 3. It doesn't matter. The x cubed is only going to be x times x times x, so I can't factor out a constant. So, you can maybe do less work, but either way, x cubed is x times x times x. Minus 18x squared. I'm not going to break down the 18, because I know there won't be a common factor, so I don't have to worry about it. So it's 18 times x, 45. Again, I'm not going to break up 45. I could do 9 times 5, or 3 times 3 times 5. I'm not going to do that. I'm just leaving it as 45. X. Right? So again, this one here, I know I can't factor out a constant, because x cubed doesn't have a constant. It's not like 2x cubed or 8x cubed. It's just x cubed. So this has an x, this has an x, that has an x. And that's the only thing you can factor out, the x. When you factor out the x, you're left with x times x, or x squared, minus 18x. There's just one x now, because you factor out one of them. And here there's no more x. So plus 45. There you go. So again, you can't always factor out a constant. Sometimes you can, sometimes you can't. One more example here, G. Let's see what G has. You got x squared y squared plus xy. So let's break it down. X squared y squared, well that's x times y times y. Xy over here, that's x times y. What do they have in common? Well, this has an x, that has an x. This has a y, that has a y. So they have xy in common. They both have xy. So that's what I'm going to factor out. If I take out the xy from xy, I'm just left with xy. If I take out the xy from xy, I'm left with nothing again. So, really, that could be xy times 1. So you're really left with just the 1 there. So when you factor it out, it's xy times xy plus 1. So that's factoring. All right, so let's zoom out again. Let me erase this. We'll see what the notes say. As always with notes, take whatever notes you want. You want to write down all the examples, or you want to write down only a couple of examples. They're your notes. I don't care which. I don't care how you take notes. In this process, above we are undoing, I guess. Undoing also is factoring. I guess we're undistributing. If you want to think of that in that type of language, we're undistributing. If you're taking back what they have in common, right? Because with distribution, I'm multiplying everything by this. Everything gets multiplied by AB. Everything gets multiplied by XY. That's distribution. Here, it's the opposite. Really, you're kind of like you're taking it this way. You're taking it away. What do you all have in common? That's what I'm taking away. So you could call that undistributing if you wanted to. The math operation we are doing is factoring. Again, that's just called factoring. Factoring. All right. So yeah, that's just factoring. Let's do maybe. Let's see. I'm at 17 minutes, so I'll do 8 more minutes of work, however long that takes me. I like to start with the ones on the right, so I'm going to start with the ones on the right. Let me zoom in. Yeah, how about 3 and 4? Do 3 and 4. 3, here we are up here, 3. So AB plus B squared plus 2BC. I mean, if you just say it out loud, you should be able to see what they have in common. AB plus B squared plus 2BC. They all have a B, right? That has a B. That has a B. They all have a B. That has an A, but that doesn't have an A. That doesn't have an A. This has a C, but there's no C's anywhere else. So B is the only thing they have in common, right? Take out a B here. Take out a B there. That becomes just B. Take out a B there. That just becomes 2C. So it becomes B times A plus B plus 2C, right? The more you practice at it, the quicker you start to see things. And again, you can always double check your work. If I multiply B times A, I'd get AB. If I multiply B times B, I get B squared. And B times 2C is 2BC. So you can always check your work. Okay, number 4, 7AB minus 35A squared B. Okay, so this one actually has a little more going on, so I will break it down a little bit more. I'll even zoom in a little bit more. 7AB. I can't really break that down more. That's just 7 times A times B, right? That's 7 times A times B. 35. 35. What can you break down 35? 35 is relatively prime. You can only break down the two things. That's just going to be 1 and 35, but this is really -5 and 7. So -5 times 7. A squared is A times A. And you got B, right? That's -35. A squared B is -5 times 7 times A times B. What do they have in common? Well, they both have a 7. They both have an A. And they both have a B. Okay, so they both have 7AB. Now, when I factor that out, what am I left with? Well, I factored out everything from this term, so I'm just left with 1. Here, I'm left with -5. And I'm left with A. So 7AB times 1 minus 5A. There's your factors. All right, let's do a couple more. Yeah, I got about 5 more minutes. 5 more minutes. I'm actually going to go with 10. 10 looks good. 10 looks good. And again, I don't know why I do this, but I'm going to. I'm going to highlight. That's what I'm doing. Number 10. 63b cubed plus 18b squared minus 90b. Right away, if you say it out loud, I definitely heard myself say b 3 times, so I know there's a b in there that I'm going to factor out. 63, I don't know, again, how, if you have your multiplication tables memorized, 63, when I hear 63, I think of 9 times 7, 18 is 2 times 9, and 90 is 9 times 10. So reading the problem, I think 9, I think B automatically, but I'll break it down. 63 is 9 times 7 times B times B times B. 18 is going to be 2 times 9 times B, and negative 90 is 9 times negative 10 times negative 10 times B. Again, they all have a B, and they all have a 9. So that's what they have in common. They have 9b in common. So there's your common factor. What am I left with? 7b times b, that's 7b squared. 2b, so it's going to be plus 2b. Negative 10, so minus 10. So it's going to be 9b times 9b times 7b squared plus 2b minus 10. My b's look like 6s to me. So it's not 96, it's 9b. I guess you can make that, you could change that if you want. If you want to make it like capital B, that makes it easier to tell what it is. But 9b times all that. So again, that's factoring. Let's do one more. I'll do number 9. Number 9, okay. Number 9, 22x to the 4th plus 12x cubed minus 16x squared. Immediately, I see they all have at least 2 x's. X to the 4th is 4 x's, x to the 3rd is 3, and x squared is 2. They all have at least 2. And they all seem to be a multiple of 2. They're all even, so you could divide them all by 2. So let's break it down. 22 is really 2 times 11 times x, right? 4 x's. 12 is 2 times 6, x. And negative 16 is going to be, I'm running out of room a little bit, but negative 8 times 2 times x. So again, they have a 2. They each have a 2. They got 2 x's, and 2 x's. So the GCF here is 2x squared. If I factor out the 2x squared, I'm left with first 11x squared here, 11x squared. Here I'm left with 6x. Here I'm just left with minus 8. So 2x squared times 11x squared plus 6x minus 8. Right? So that's just factoring. There it is. You should have done it before. Hopefully you remember it from Algebra 1. I know I do. Last thing we'll look at, again, so factoring the GCF means that we are factoring out a single term. One term. Also called a monomial. One term, mono means one, nomial means like term, monomial is one term. On next lesson, so on Tuesday or Wednesday, depending on the class, we're going to be talking about factoring out 2 binomials, but just to you ready, I want to remember, because again, factoring and distribution or multiplying are sort of the opposite. So before we get into factoring into 2 binomials, we're going to hopefully remember how to multiply 2 binomials together. Remember, zoom in here. These are binomials, right? Because x plus 4, that's 2 things. 2x minus 3, that's 2 things, 2 terms. means 2. Like binary is like two numbers, a system of 2 numbers. When we multiply together, what's that process called? You might remember it as a couple of things, but I think what they're getting at is foiling. I'll do it like this. Foiling. If you don't remember FOIL, that's going to be what? First, outer, or outside, inner, last. There you go. That's foiling. Hopefully you remember foiling. Let's do 2 examples of foiling just so you can remember what the heck it is. We'll do C and D. C and D of foiling. Okay, so in foiling is really just fancy distributions, not anything too much harder. Right? There's that, C. So you should multiply them. So first, so this is the first. 3x is the first here, x there, right? 3x times x. Well, that is 3x squared. Outside, so these are the outside terms. 3x times -2. 3 times -2 is -6. Inside, -1 times x, that's -x. And then finally, the last terms are -1 and 2, which is -1 and -2, which when you multiply that is +2. Right? So combine those middle terms, you have 3x squared. -6 minus 1 is -7x plus 2. There you go. There's some foiling. Hopefully you remember that. We'll do one more example. 3x plus 1 times 3x minus 1. This is actually a fancy, special type of problem, but we'll probably talk more about later. 3x times 3x is 9x squared. 3 times 3 is 9. X times x is x squared. 3x times -1 is -3x. 3x times +1 is positive 3x. Then 1 times -1 is -1. Combine the middle terms. You have 9x squared. These cancel out. -3x plus 3x is nothing, so they cancel out. Then you have -1 here. Right, so that's factoring. No, sorry, that was factoring earlier. This is foiling, which will go in. They kind of go hand in hand. Factoring and foiling, they're, again, opposites. But we'll talk more about that for you guys on Tuesday or Wednesday in class. All right, so there's a video, a little bit over 25 minutes. There's the notes. I did the second half on most of them. So the other ones I'll probably do in class. All right, so there it is. I'll see you guys in class.